My name is Ajay Kumar, working for Dikix Interwire Internet Services, who is running internet exchanges in India. So I will be the moderator of this session. As I have already mentioned that we are running late. So let's start first talk with what's going on in the internet world of the DNS. Speaker is David from ICANN. Over to you. Can you move?
Okay, so I'm back, thank you. And today we're going to talk a little bit about what's going on in the world of DNS. And what this talk is it's for network operators who spend most of your time building and maintaining your network. And DNS, of course, exists and it's important, but it's not always that easy to keep up with some of the more interesting current topics that are happening in the DNS technical community. So this is just a very short talk to help bring you up to speed. We're going to talk about four things today. We're going to talk about what we call applications doing DNS, ADD. We're going to talk about public DNS and the issues that public DNS bring about, which include resolver centrality, the centralization of resolvers. We're going to talk a little bit about an attack recently called DNS espionage. And finally, because I work for ICANN, we have to at least give one slide on an update on the KSK role. So let's talk about applications doing DNS. If we think about the traditional DNS resolution model, we have stub resolvers on the user's device, recursive resolvers, which were often run at the service provider level, the ISP, the enterprise, the university, and of course the authoritative server, which lived wherever. And it's interesting to note that because it was the service provider controlling the recursive resolver, many of the needs of the service provider are met. Regulatory needs, they're met. Filtering needs, malware protection, easy to implement, good procedures, good protocols for doing so. But this traditional model has had security concerns and privacy concerns for many years. Sarah Dickinson, who's a developer in the DNS community, is quoted as saying the DNS is actually one of the most significant leaks of end user data anywhere on the internet. DNS queries are sent in clear text, which means anyone doing passive monitoring can see them. They contain really interesting data, who we are, our IP address of the host device, the query names that we're querying, the date, the time, and all the metadata. And a lot of people point to VPNs as a solution for some of the privacy leaks of DNS data, but they're not, because if you actually look, a lot of VPNs, when they start to do a DNS query, they actually send it outside the encrypted channel, right on port 53. And because of all this, it turns out that the DNS queries and responses between the recursive resolver and the stub resolver are the most vulnerable to being censored or being rewritten. So one solution, of course, is to encrypt, right? If you encrypt each of the queries and each of the responses, you get assurances that the queries cannot be looked at, they can't be snooped, and you're eliminating any man-in-the-middle attacks. So in 2017 and 2018, the IETF standardized two protocols for DNS query encryption: DNS over TLS, DOT, and DNS over HTTPS, DO. So from a technical perspective, DNS over TLS is RFC 7858, and of course it's taking advantage of TLS to encrypt the DNS traffic between the stub and the recursive resolver, which gives users, of course, the authenticity and their confidentiality of their DNS queries. When you see DOT traffic on your network, it's not on port 53 on UDP, it's actually on port 853 on TCP. And you'll most often today see that these are being used by email and mobile applications doing their own DNS on 853. Now DOH is the big one. This is the big conversation today. And I want to separate how DOH is implemented from how DOH was designed. The protocol goals, RFC 8484, of DNS over HTTPS are actually very benign. It's a simple idea of who do you really want doing your recursive DNS resolution? So the canonical example for Do is, look, I trust my bank because I give them my money. And not only am I giving them my money, I actually trust them to do banking over the internet with them, which, for many years seemed like a really bad idea. But we trust them enough to do it. So if I trust my bank to give them money, and I trust my bank to do transactions over the internet, maybe the bank might be the organization I trust the most with all of my DNS traffic. So if my bank were to set up a DO resolver, I could choose them instead of my service provider, instead of perhaps a public DNS provider who I don't know. And it gives me, as the end user, the power to decide who I trust. And that became the Trusted Recursive Resolver model, the TRR model. It empowers the users. DO runs on TCP, of course, and it runs on 443. The DO traffic is completely indecipherable from all the other web traffic inside an HTTPS connection. And that's a problem. In the real world, that's a problem. So if you're a service provider, if you're an ISP, and if you're an enterprise, you can't use the DNS anymore to meet some of your requirements. When your state, when your government, your federal government tells you when your users are trying to make DNS lookups of this prohibited content, you must do something. Rewrite it, block it. You can't do that anymore when the applications are completely bypassing your resolver. And they're not only bypassing your resolver, they're encrypting the traffic so you can't see what the user on the application is looking up. Another concern that service providers have with DNS over HTTPS, or generally actually just with applications doing DNS, is that what happens if it doesn't work? What happens if I choose to use my bank as my DO resolver and one day, a few months later, all of a sudden DNS isn't working? Well, you know what? It turns out users actually call the service provider. They say, hey, you're the one I pay for internet service, and I can't get to any websites anymore. And now the service provider is put in the awkward situation of wanting to help the customer, but what's broken is something that's well outside of their control. Parental controls is something that's come to the surface very quickly. We have folks who use, very technically savvy folks who use response policy zones or other types of content filtering with their ISPs to protect their children from content they don't want their children to see. Well, if the child is using an application that's doing its own DNS and it's doing over an encrypted channel to a DO resolver that doesn't have any of these controls, all of that parental control goes out the window. Finally, of course, there are not just the federal government, but also courts. When courts often, as you know, order ISPs to do certain things. And you can't do those certain things anymore for your users when your users are completely bypassing the infrastructure you've built to support that. But if we take a step back from the service provider concerns, we have to think about applications doing DNS as a challenge just for broader public policy. Which laws apply to applications doing DNS? In the traditional model, the recursive resolver providing the answers is generally in the same country as the user. It's provided by the service provider, which, generally speaking, is going to be in that country. And we know what legal jurisdiction applies. But in applications doing DNS with DO resolvers all over the world, it will very often mean that's not the case. The DO resolver is going to be in a different country. So from a public policy perspective, whose laws apply to a DNS query? These types of things are going to be very important to think about when you look at content filtering laws and end user privacy, data privacy regulations in your country, in India or anywhere else you're operating, because it's not as simple anymore. It's very complex. Another concern is who gets to determine the resolver. I talked about what the policy envisioned. The policy was very benevolent. It was empowering the user to make the choice that works for her. But it turns out nothing stops the application maker from making the choice for the user. What happens if the application maker is not honest? What if they're purposely using a resolver that isn't what the user said, but instead is a resolver that, you know, financially or somehow benefits the application manager, the application maker? What if the application maker or the DOE resolver is monetizing your data without your knowledge, without your consent? The point is that bad or dishonest implementations of applications doing DNS actually disempowers end users, and does so in a context which end users generally don't know a thing about. I repeat what I said this morning. End users don't know what recursive DNS is. They don't know what authoritative DNS is. They just know they want to get to this site. So we have to discuss these things. DOT and DOH are very, very new protocols. They're 1 and 2 years old, and they're very quickly being implemented in lots of applications that our end users use all the time. We need to discuss these. We need to bring these topics to the surface, and we need to come to resolutions. And we need to do so together. So I asked the question on the slide, where does this occur? Does it occur at ICANN? Does it occur at NOGs like INNOG? Does it occur at Center or IETF or at the CAB forum? Do the regulators talk about it? And you know, the answer is probably all of the above. We need to discuss these things as service providers in the network operator environment, but you also need to be discussing it with the policymakers in your regions and in your countries. So, some last thoughts about applications doing DNS. Applications doing their own DNS is new, but it's very quickly being implemented. Privacy is a major regulatory, and it's a societal concern. Encrypting DNS data with TLS or HTTPS is probably really good for our users, but implementation details matter, and there are public policy concerns and there are regulatory concerns about how ADD is implemented and what these negative effects can be. So I want to talk a second arena about the DNS, which is about public DNS and the conversation about centrality. Our friends at INNOG recently conducted some measurements into the centrality of recursive resolvers. And they asked the question, how many recursive resolver operators does it take to cover 50% of all the queries that exist? It turns out their answer is about 8 or 9. You could answer half of the world's DNS queries with just 8 or 9 public DNS resolvers. Google, 8.8.8.8, answered in their study about 33% of all the queries that existed. There were other big global resolvers that answered a very large proportion of queries, including, unsurprisingly, China Unicom, China Mobile, DNS Pi, which is also in China, Comcast in the United States, and then the Cisco's product OpenDNS. There are lots of public DNS operators today. One of the trends from a marketing perspective is the Quad name, right? We have Quad 1 from Cloudflare, Quad 9 from IBM and Packet Clearinghouse, Quad 101 from our friends at Taiwan NIC. Some of these operators are banking and use a value proposition of this is how fast our queries can resolve, and some of them use privacy. We won't even store your query logs as their value proposition. But do you notice something about this? They all market with an IPv4 address. But it's funny because they all do IPv6. I showed this graph this morning. In December, most of the queries all came in under IPv4. But all of these can do IPv6. And that's important because as we've discussed today, as our friends from Reliance Jio and our friends from Tata showed, IPv6 is driven by scale. If we look at the largest IP networks in the world by subscriber count, we have 2, China Mobile and Reliance Jio. I gave you an extra 100 million subscribers, if that's okay. Scale is what drives IPv6. We saw that. We saw the numbers. We saw the case history. The DNS queries on these follow the same thing. 90% of the queries are resolved over IPv6, and only 10% are resolved on IPv4. And this leads into the centrality dilemma. The popularity of public DNS can actually be a very, very good thing for network operators, right? It's about cost. You don't have to build out a recursive DNS service. It's about operational costs. You don't have to maintain it anymore. if you're getting big, you don't have to worry about scale because you just point to everybody, hey, just please use 8.8.8.8. And what I've learned here in my trip to India is this is actually a very common setup in service providers all around this country, which is we're not going to spend the money and the time, the operating capital, the human resourcing. We're not going to do it on a recursive resolver service because people are already doing it in a really good way. 8.8.8.8 works. It's worked for 10, 15 years now. It works. Cloudflare, PCH, TWNIC, these organizations take this very seriously and want to provide the best quality public DNS they can. And this is generally very good. But then what happens if all of our DNS queries are only going to these 8 or 9 public resolvers that APNIC identified in their study? We get a very small number of organizations making decisions for a very large number of people, billions of people having DNS decisions made by a small number of companies. And that matters, because what happens if they decide we're going to support this new protocol feature, or we're not going to support it? Google is the single biggest driver of DNSSEC in the world. And as we're going to see in just a few slides, it's never been more important to have DNSSEC. But what if they decide, no, we're not going to support that? Well, that makes a difference when we have a tremendous amount of centrality in our resolution. Over-centralized recursive service prompts numerous concerns about content being resolved. What happens when one of these big public DNS resolvers decides to start doing content filtering? What happens if they just decide to augment the namespace by inserting their own TLDs that the public hasn't approved? You know, Twitter and Facebook and some of the other mass media companies have tried in the past to implement automated content filtering, and arguably it hasn't worked out so well for them. But think about that at a DNS level. If a public DNS operator, a group of DNS operators, decides to do their own content filtering, think about how many people that affects. Think about that scale. It's a lot bigger than Twitter. DNS espionage, it's a really sexy name. I don't know who came up with it, but thumbs up to them. So DNS espionage happened in late 2018, and an offshoot of DNS espionage is going on today. It's called Sea Turtle. And if you take nothing else out of this presentation, you get this really cool phrase called military cyber offense pre-positioning. What's happening here is somebody is gathering the intelligence that they need from systems in about 40 organizations in about 13 countries, all in the Middle East. They're gathering all the intelligence they need to launch a future cyber attack. We think they've generally been targeting national security organizations, ministries of foreign affairs, and of course energy companies, high-value targets. The methodologies are very, very, very interesting. The way they do these is through very short attacks, 10-minute attacks. And the reason they do it in 10-minute attacks is to avoid monitoring systems. It turns out if you really take a look at what you're monitoring on your network and what you're looking for in vulnerabilities, you're generally not looking in very small windows. You're generally polling once an hour, once every few hours. If they do it in little 10-minute discrete attacks, it bypasses a lot of the monitoring you're doing. Through other means, through social engineering and other normal types of attacks that hackers do, they've been able to compromise the extensible provisioning protocol that exists between registrars and registries. They've been able to get the login credentials for domain names, the login credentials for whole registrars. And with that, they're able to rewrite the authoritative name servers for a domain for just a few minutes. And when you've done that, you're then able to start harvesting data as people log in and using the wrong name servers and getting to the wrong sites and start putting in their login credentials for the systems that you're trying to compromise. It turns out it's actually quite simplistic to start harvesting those credentials. And one of the things that they really focused in on was IMAP. When your IMAP authentication servers are visible to the internet, and not just visible from within your own AS, typically accessed through a VPN, it turns out you've given them the keys to a lot of your kingdom. Capturing email credentials is not just about capturing email, it's about capturing your calendaring, about the vCards. It's about a whole network of information that a nation state can use to pre-position the information they need for a military attack. So in studying DNS espionage, there are some obvious improvements we need to lock down our systems better. And one of them is called Registry Lock or Registrar Lock. And it turns out we actually don't really know what this means as a community. What is Registry Lock? It's where you're supposed to be able to lock down your record so that nobody can change it until the registrar that you work with has actually validated you when you're making the request to make an update. It's not just coming from David's email at ICANN. They actually take extra steps to make sure it's really me. But not all TLD registries offer it. And if you actually go try setting it up, if you have a registry that offers it, you try setting it up, it turns out to be actually quite painful. So we've learned we need agreed upon definition of what registry lock is, what it should be. So there's some policy work in the ICANN ecosystem that needs to get done here. I've already talked about DNSSEC monitoring. Not every hour. You actually need to poll every minute for your DNSSEC signed domains. And then, of course, the C8, we know that certificate authorities have some vulnerabilities just in the structural setup. The CAB Forum has done some really good work in improving this over the years, but there's an argument out there that Dane may be a better choice for real security. The bigger lessons learned, of course, is that the DNS is the key to the kingdom. When you can rewrite the authoritative name servers for all these different sites and harvest credentials, that's really bad. So it's very important that you sign and validate all of your DNS data. Better security hygiene, and of course more emphasis at the top on resourcing your security. All right, as a final update on what's going on in the world of DNS, I just wanted one quick slide on the KSK roll. We did roll the KSK on October 11th of last year. And one of the things we've learned from it is we don't quite know what happens when you roll the KSK. We can't measure it ahead of time, and we can't predict it ahead of time. As evidence, we saw a couple operators go down after the KSK roll, but these operators don't participate in any of our common forum, in our NOGs, in our DNS technical community, so we still, many months later, don't know why they went down. We also saw the number of DNS queries in the DNS space just explode the moment the key was rolled. And it exploded, and we couldn't figure out why. Everyone's rushing around trying to measure this and see what's going on. And then the moment we revoked the old key, they went away. So that's actually a really interesting opportunity for some of our DNS researchers. So moving forward, the IANA owns the decision-making on what we're going to do next. Are we going to roll it yearly? Are we going to roll it every 2 years, every 5 years? Oh, and by the way, in addition to rolling the KSK, the key signing key, we really need to think about rolling the algorithm we use to generate the key signing key. So, applications doing DNS, it's very real, it's very near now. As a network operator, as a regulator or public policymaker, it's a good time to start paying attention to how vendors implement ADD. In the broader conversation about end-user privacy rights, the DNS is now front and center. You need to consider how better end-user privacy in DNS reconciles with certain top-down regulations. And DNS abuse continues to be an issue. Since DNS is a gateway into your systems, it is really important to prioritize it in your policy making and in your operational security efforts. That was quick, I know, but I just wanted to bring you up to date as network operators and some of the things going on in the DNS world. If you have any questions, I'd be glad to take them. All right, let's get back on track. Thank you. Oh, no, honor.
Great talk, David. Thanks. Anurag from Hurricane Electric. You mentioned about applications doing DNS is getting common. I was curious if you can name some of the applications. The one I know, which is getting quite a lot of fame and shame for doing that, is Firefox.
Yes.
Do you know any other popular applications who are starting to use resolvers of their own choice, ignoring the ones supported by the operating system?
It's a really good question. Actually, I don't have the names. That's a good challenge. I don't know what the names of the specific applications are. Firefox is what we concentrate all of our firepower on.
Yes.
Basically because of their implementation choices.
All right.
But yeah, no, it's a good question. Thank you.
Cool. Thank you.
Yeah.
Hi, this is Ramesh Chandra. See, what happens is in the DNS resolution, assume if there is a cache ratio, maybe 95-98%, still 2% query goes to the root. And when it goes to the root, obviously it depends on where the root available, going to take time and then it is going to delay the resolution for the end customer. How do we protect? How fast we can serve even these 2% of the subscriber queries is the one question. We are aware about the fact that yes, it is not the server, cache server or cache DNS who decide whether TTL is coming. Now we are aware of the fact, yes, if we increase the TTL, maybe if the IP address is changed, then it will take time to in fact get updated. So our guess is that if we increase the TTL value to a longer period, IP addresses are not changed frequently. It will help the industry to avoid and minimize the recursive queries going to the internet or to the root servers. What is your view on this?
Can you just repeat the very last sentence? Because I just lost it. The very last sentence. I'm so sorry.
Yeah, so question here is the trade-off.
Yeah.
Whether we should have a longer TTL value and minimize the number of queries going to the root server versus if we have a smaller TTL value, this requires a multiple recursive queries.
Yes.
So we understand the fact that IP addresses are not changed
Right.
frequently for the domains. If that's the case, we don't see there is a risk of increasing the TTL value to longer period. If we do that, it will help to minimize the number of recursive queries going to the root server, and it will help to the end subscriber to resolve the queries faster.
So I have a couple of different responses to that. The first, of course, is you're asking the question. And you're in a different situation than most everybody else in the whole world, and certainly everyone else in the room, because you're providing recursive service at a scale that's tremendous. And these questions are really, really, really important, right? In a mobile environment, a long TTL, I think, is very justified. Because, as you say, for the most part, the sites people are going to involve IP address that don't change very commonly. I completely agree with you. It turns out, though, there are applications that need a TTL as short as 300, the minimum, because they're constantly dynamically updating all the time. It's part of how they do business. But I don't think that applies in the service provider world. We're network engineers, we're network operators serving thousands, tens, thousands, millions, or hundreds of millions of customers. In this case, long TTLs benefit us, they benefit our end users, they benefit the DNS. If you set your TTLs too small, you're going to destroy some of the authoritative servers that are upstream of your recursive farm. So, I mean, I generally, the premise of your question I'm generally fully on board with, which is long TTL, or a standard TTL that we use is good.
So if this is the case, if there is a use case, is there any initiative can be taken even to the people group who is maintaining the root servers, how this can be taken as an initiative to improvise? If there is a possibility, at least there is a thought and discussion. If we can take up this and then explore, if we do it, is it really going to benefit to a larger community? And of course, some of the applications where they need a frequent change of the IP addresses, they may continue to run with the shorter TTL.
Yeah. So this is what the RSAC is for. This is what the Root Server Advisory Committee, this is really their purpose, is we can bring these types of questions to them, and then they can actually do real world experiments and study these and come back with good answers and good recommendations.
Thank you.
Rajesh Jain from Shyam Spectra. My question is, can service provider not force all the DNS queries to its own recursive resolver, from whichever source it comes?
No, they cannot, because with the popular one, DNS over HTTPS, it's the same as web traffic. It's HTTPS traffic. So unless you stop your users from being able to browse the web in a secure and authenticated, in an encrypted manner, you can't stop them from also doing DNS over HTTPS, except perhaps from a regulatory approach which simply bans it. But then the onus is actually on the application maker. I'm not recommending that. I'm simply saying one of the the reasons we're discussing this is this isn't a solution that a service provider can just force.
No, in India, being a large democracy, banning is not an option.
Right.
It is a very difficult option for any government to operate. And the browser you ask is another is the UC browser. You ask the name of another browser, UC browser is the one.
Thank you very much, David, for giving inside the DNS what's going on in the world. And thank you very much for audience for making the session interactive.